So today's topic is special right triangles, and we've been talking about right triangles and how you can find missing side lengths using Pythagorean theorem. A squared plus b squared equals c squared. But now what we're going to do is we're going to show you that sometimes you don't have to know two sides of a right triangle to find the third. But this only happens in your special right triangles. Today's topic is going to be the 45, 45, 90. So in a 45, 45, 90 triangle, a lot of times you'll see this, and you've done problems like this already. We're going to use this square, and we're going to label each side of the square with a length of 1 unit. All right, so we're going to go ahead and just mark this each side 1 unit. And then it also says to mark the right angles, because we know squares have 4 right angles. All right, now it says to draw a diagonal to create a right triangle. So your diagonal goes across, goes through the middle from one angle to another. What is the length of each leg? So if you notice right here, we've created a right triangle, and I want to go ahead and note that these are your legs, the sides of the square, and then your hypotenuse is the diagonal. So when it asks you what is the length of each leg, we're going to note that it's just 1 unit. What is the length of the hypotenuse? Well, the length of the hypotenuse, we can find that by doing Pythagorean theorem. So I know that my legs are both 1, so 1 squared plus 1 squared is equal to c squared. 1 squared is 1, so if I add those together, that is 2 is equal to c squared. But now to get the actual side length, I need to take the square root, so that I now have the square root of 2 is equal to c. So our hypotenuse has a length of the square root of 2. I want you to notice that this special triangle, it says to classify it by its side lengths. Well, if we see that we have 2 congruent sides, remember last semester we talked about isosceles triangles. Isosceles triangles have 2 congruent sides. This is an isosceles right triangle. And when you have an isosceles right triangle, you also automatically know the acute angles, because that is 90 degrees cut in half, so those are both 45-degree angles. So the measure of your acute angles is 45 degrees. This asks for the extended ratio of the side lengths. Now, we talked about that on our last unit, about extended ratios where we're comparing them all. Well, our extended ratio, what I want you to notice is if you have a side length of 1 for your legs, and they are the same, then you're going to have a hypotenuse with a length of root 2. What this means is our legs are going to be the same, but our hypotenuse is going to be the square root of 2 times greater. So let's go ahead and acknowledge this. These as our legs, and this is our hypotenuse. So every right isosceles triangle, every right isosceles triangle has this same ratio. Has this same ratio of 1 to 1 to the square root of 2. So, what is that? Why do we care? This is our shortcut, so we don't have to do Pythagorean theorem to find missing side lengths. The leg, either leg, the leg of the isosceles right triangle times the square root of 2 will equal the length of the hypotenuse. So this is all you really need to know. So if you know the leg, you take it times the square root of 2. If you know the hypotenuse, you'll solve by dividing. So the leg is equal to the hypotenuse divided by the square root of 2. And this, folks, is why we practice simplifying radicals, so that we could leave this in exact form. But these are basically the formulas you're going to lose. And you will see it is so much quicker than using Pythagorean theorem. But you can only do this if you know that this is a 45, 45, 90 triangle. So let's do some example problems. So notice that you've got a right angle and that you've got two congruent sides. That means it's isosceles. And if it's isosceles, that means we've got congruent angles right here, and those are 45 degrees. Now, we know the length of a leg. This is our other leg, and this is our hypotenuse. It says find the missing side and the hypotenuse. So if this leg is 20, then I know this leg is 20 because our legs are the same. They are the same length. Now, to find my hypotenuse, look right here. We take the leg times the square root of 2. So since my leg is 20, 20 times the square root of 2 equals the hypotenuse. And all that is 20 root 2. Do not put that in your calculator. Just leave it in simplified radical form. And you're done. Okay. This next example, they're finding the missing side lengths, but now we know the hypotenuse. Let's label that. And now we're working backwards because now we need to find the length of each leg. And again, these are marked congruent, so we know that these angles are congruent, so it's a 45, 45, 90. So, if our relationship is you take the leg times the square root of 2 to get the hypotenuse, then we can divide the hypotenuse by the square root of 2 to get the leg. See, all we did was divide both sides by the square root of 2. So to find my leg, I'm going to take my hypotenuse and divide it by the square root of 2. Well, what's root 2 divided by root 2? That is a common factor. It reduces, take that out, and this is equivalent to 1. So 4 times 1 is 4. So each leg has a length of 4. 4 units. And you're done. Got a word problem. Draw a picture. What is the length of the hypotenuse if the legs, and this should say of a right triangle, are 14 inches? So let's make a right triangle, and each leg is 14 inches. What is the length of the hypotenuse? So I take my leg times the square root of 2 to equal the hypotenuse. So that answer is just 14 root 2. And you can't tell me that that is more difficult than Pythagorean theorem. But you just got to know your relationship. All right, the next one, if we have a square, and they are giving us, if the diagonal is 25 inches long, we want to find the length of the sides. So let's draw a picture of a square. The diagonal is 25. There's our right angles. We know the sides are the same. So this is what we're looking for right here. So x times the square root of 2 is equal to 25. right? The leg times the square root of 2. So we divide. X equals 25 divided by the square root of 2. Remember, we can't leave a radical in the denominator, and if I want you to leave your answer in an exact radical form, we have to multiply by the square root of 2 over the square root of 2. So we get a perfect square in our denominator. Our numerator would be 25 times root 2, and our denominator would just be 2. That looks like a funny answer. You could write that as 25 divided by 2, and that would be 12.5 root 2 if you like that answer better. But both of these represent the same thing. I would accept it either way. So now, what I need y'all to do is you're going to practice those two problems on the back that you're going to practice on your own. They're all 45, 45, 90, except for the last one. I accidentally boo-booed and put a 30, 60, 90 in there. So here's what you're going to do. You are going to draw a triangle. That is a 45, 45, 90, or actually, all we know is these angles are x, the hypotenuse is y, and the leg is 12. I want you to find the x and the y based off this information. Alright, and when y'all are done, you can check your answers with my key. Y'all have a good day.